All right, this is new stuff. I'm going to show you how another way we can look at mechanisms. There's a lot of ways. There are a lot of ways that I'm going to ask you questions about mechanisms. Sometimes, like I did in the previous examples, I just did some practice on again. Sometimes I'll give you the whole rate law expression, and I'll say, what will happen if I double A or triple B? Okay, I'll be asking you, what will the effect on the rate be? That's one way I could ask a question. Here, I'm going to be asking you a question to tell me, I'm going to give you a mechanism, and I'm going to give you a rate law expression. I'll say, is that mechanism consistent with the rate law expression? I'll be seeing if it's consistent. Notice how I phrased that. I didn't say, is the mechanism correct? Is it proven? I can't prove a mechanism. Fact is, I can't see what's going on at the atomic level in matters of milliseconds. Okay, I can't see ions and atoms combining into each other. I can't see electrons being transferred. No one can prove a mechanism, because in order to do so, you'd have to be able to see what was going on down there, and you just can't. But just like my analogy, it was a very good analogy. It wasn't just for fun. 3 people standing up here, okay? I can't watch them work. All I can do is see how fast those widgets come out at the other end of the assembly line. So without knowing exactly what's going on, can I tell who's the problem? Can I tell who's in the slow step? Sure. What can I do? Yeah, I can test each one. I can give a helper to who was at the very end here yesterday. All right, so Lexi was at the very end. I can give a helper to Lexi. She was waiting around most of the time. I give her a helper. End of the day, the widgets came out the exact same rate. I give a helper to Maggie on the other side. Nothing happens again. But if I give a helper, if I double the concentration of Kaylin, the one that was in the middle yesterday, I double that concentration, I'm going to double the rate. So I know that she's... Now, do I know exactly what's going on? Can I prove a mechanism? No. Sometimes there's more than one possible explanation. And I'm not exaggerating when I say there are actually chemical reactions in chemistry that real chemists don't know which way necessarily a mechanism is going to go. All right? There is more than one possible mechanism that guys can undergo. All right? So you can't prove a mechanism. These are just ones that are consistent. I'm going to see if it's consistent with the rate law expression. So that's what I'm going to teach you how to do. Now, this actually, I think, starts out pretty simple, but it's going to get pretty complicated. And that's why I've redone this class, and I'm taping it today. I used to do this kind of in class. I really only had one example on the board because they kind of take a long time to write down. And I would, after I did my one example on the board, I'd sit down with you, and in class we'd do together a whole bunch of these. Well, video-wise, obviously that's a problem. Because if you're only seeing one example, you really don't see all the nuances, all the tricks of the trade. So I want to show you, that's why I'm taping this class. I'm going to show you multiple examples on the board. I did simplify them so they become relatively easy to write down, but they still do require quite a bit of writing. So let's take this guy as my first example. You ready? This is my overall reaction. And I tell this to you in the problem. I say, you've got CO plus NO2, you have CO2 plus NO. And I'm leaving out, to save some time for writing, leaving out the states, gas, solid, liquid. Leaving out all that stuff, kind of shortening things up so you can just see what's going on. Matter of fact, I'm going to shorten up even more on my next examples. The next board, I'm just going to use A, B, and C's. I'm not even going to use compounds, so shorten it up even more. Because it is a pain writing all this crap out. As a matter of fact, on your homework, because I'm doing this with you, I'm not going to require you to do it on the homework. On the homework, all you'll have to do is put, when I check your homework, consistent or not consistent. Just one word. For like 66 and 75, that's all you're going to have to write is a word. You're not going to have to rewrite all this stuff like you're writing now. Okay, in the same problem I give you, this is also part of the given information, I tell you the rate law expression for this guy is that. Okay, so that's all given. Now, I don't want you to copy the next things that are going to come up under here. I want you to just listen. I will stop when I'm done going over these, and you can then you'll have to copy it all down. But I find that because people copy at different rates, and there's a lot to put on here, that I end up talking over you. I don't want to be talking over you. I want you to be listening. So here we go. Don't copy this. Let me give you 3 possible mechanisms. You tell me which ones are true, or which ones are consistent. I can't say if it's true or prove it, but which ones are consistent. Here's mechanism 1. I simply take CO plus NO2 in one step, whole thing happens. Mechanism 2, again, you're not copying. 2 steps. Mechanism 3, 3 steps. Okay? Look at that. See if you can figure out which of those would be consistent with this equation and that rate law expression. Raise your hand when we're talking about the first one first. Do you think the first one is consistent with this rate law expression? Raise your hand if you think you know. What do you think?
It is.
He says it is. So he thinks, now if there's only one step, that is the slow step. If there's only one step, these guys are both involved in it. They're the only step there. It has to be the slow step. It's the only step. If I were to write the rate law expression for a guy who uses CO and NO2, both of them are involved in the slow step, would the rate law expression look like that? Who's missing from here? CO. CO's in the slow step, but he's not in the rate law expression. According to the rate law expression, CO is 0 order, isn't it? Has no effect on the rate. But according to this, it has to have had an effect on the rate. No. If I were to have written the rate law expression for this mechanism, it would have looked like this. Rate would have equaled K CO times NO2. Both to the first power, because they're both used one time in this only slow step. So that is not consistent. Again, you're not copying anything down. We'll give you a chance in a second. Is the second one consistent? What do you think? Taylor?
Yes.
Yes, it is. Let's see why. The second one has the slow step where it's using NO2 twice. That's nice, because here it is. NO2 is supposed to be used twice in the slow step. That's what that exponent's telling you, right? And then later on, it picks up a CO in a second step that's very fast, kind of like whoever was over here. Lexi was over here. You know, she really doesn't have any effect on the rate. But NO2 has twice the effect because he's used twice in the slow step. So he is consistent. Yes, he is consistent. Is the last one consistent? What do you think? No. And let me ask you, if I were to write what would be the rate law expression for this guy, what would he look like? What would it be? Rate would equal what? K what? CO to what power? To the first, right? That's it. You see why? Because the only guy who's in the slow step is CO. These guys are in later fast steps, so they really don't have an effect. So this first example is a lot to write down, but it's pretty straightforward. I think most of you could probably get this right. I want you to copy all that down. And then we're going to go on to some harder ones, but I'm going to shorten them up and use letters instead of actual compounds. This is just the second way we're talking about mechanisms. The second way we're looking at reactions. There's other ways we're going to have to do these. We're going to have to eventually get to the point where we can come up with the entire rate law expression and actual numerical values for them, not just, you know, does it double, does it triple, is this guy in the slow step, is he not in the slow step? I'm talking about numerical values for every value in the rate law expression. We are going to get there, but we're not there yet. We're still basically in the theoretical part. And I'm trying to ask it multiple ways so I make sure you understand it. So this is kind of like working backwards almost from what we did yesterday. Yesterday I was asking about what would the effect of the rate be given the rate law expression. Here I'm asking you, what do you think about the mechanism is going to be given the rate law expression? It's not really working backwards, but it's definitely looking at it from a different angle. I know there's a lot to copy down, but try to copy it down fast because I want to get to the other stuff too. All you got to write down next to each of these, by the way, is what? Either not consistent. Where is this thing's off today? Terrible. Look at that. And I've already redid it twice. Not, this guy is consistent and this is not. Right? So that's all you really have to write for those. And that's all you'll have to write for your homework. I don't want you to have to read. That's a lot of busy work. Having to rewrite every one of those, a page worth of this stuff isn't really necessary as long as we have enough examples in our notes so that it'll make sense to us later on. I still want you to try them, obviously, but I don't need you to write them all out. All right, everybody done?
No.
Hurry, come on.
Can more than one mechanism be?
Absolutely. Good question. I meant to mention that. Can there be more than one consistent mechanism? Absolutely. And you're going to find that when you do the homework. There's more than one possible answer, and you need to write down. You may have 2 or 3 yeses. I think one of them has 3 yeses that are consistent and 2 that are inconsistent. All right, let's take a look at the next guy. Okay, this is example 2. Here's my overall reaction. Notice I'm going to shorten it up now. It'll be a lot easier. We'll do these along. It'll be just using A, B's, and C's. If I give you the overall equation, A plus B yields E plus F, which of these mechanisms would be consistent with that? Let's take them one at a time, instead of putting all 3 up on the board like I did last time. By the way, I think some of the homework problems have like 4 or 5 even possible mechanisms. All right. Look at this guy. You think this guy's consistent for mechanism? Oh, by the way, I have to give, obviously, if I had just put up my next one without the rate law expression, could you have told me the answer? No. All right, so here's the rate law expression. Okay, let's take a look. First mechanism. Do you think this guy's consistent? One step. What do you think? Lexi?
No.
No. If that were the correct mechanism, people, what would the rate law expression, what would be different about the rate law expression?
It would be second, it would be first.
Exactly. That would be a 1. Oops, I moved. That would be a 1 up here, right? It'd be A, B. That's it. Okay, good. Very good. That one is not consistent. You put an X next to him. What about this guy? Write the whole thing out and then try to think, see what you think. Now, first thing that may come to your mind, I know probably you're getting this idea, and it's a smart idea, all right? We've been doing this for a couple of days, and right now you're probably thinking to yourself, okay, I really have to look at it as a slow step. Well, I have to look at anybody else, right? Sometimes not. Okay, you're thinking to yourself, oh, I really need to look at it as a slow step, and then you go and look at this slow step, and there's a guy in there that isn't even in the equation. He's not even in the rate law expression. Well, what am I supposed to do with that guy? Well, this C is what we call an intermediate. You notice what happens to C in this case? You've seen this before in Hess's law, haven't you? Okay? You've seen this before. C is formed here, and then he's used up here. Same as what other guy does that too? D is formed here, and then he's used up here. Right? Well, what do you think? He's what's called an intermediate, and he will not be in the rate law expression, but he does affect it. Because A was turned into C and E. And that intermediate is used in a prior slow step. Guess what? It's like using A in that step. So A is being used in this step because C is being used there. And A is also being used because he's right there. How many times did I use A in this problem? Twice. So far, so good. That looks good. A squared. That is A squared. But did I use B at all in the slow step? Was B used at all? No. B wasn't used until a fast step. So the rate law expression for this guy, had this been the correct one, would have looked like this. Rate would equal k a squared. You see it? But so that's, again, inconsistent. So these first two are both inconsistent. Now, I just made these up to make for this class, and I hope I put one that is consistent because I did it pretty quickly. Let's see if this last one is. If it isn't, I'm going to probably change it for you just so make sure it is. Okay, copy him down. Is this last mechanism consistent? Yes, it is. Yeah. And that's, again, it has to do. I know these are tough. I told you these are easier to write down and easier to see because they have A, B's, and C's. But they're tougher because they have what are called intermediates. Let me show you with this guy. All right, we've seen this before with an intermediate. We saw a C be produced, a D be produced, and then used up. And if the intermediate is used in the slow step, it's the same thing as if the guy who formed that intermediate was used. So, does that happen in this case? Let's take a look. We have this intermediate form, C. C was formed from both A and B in a prior fast step. So when you have C, it's really like using an A and a B at the same time. So really this equation is kind of like A plus B. Does that fit? Yes. 2 A's and 1 B all in the slow step because an intermediate formed from a prior fast step works. Absolutely. So this guy is consistent. Yes. Absolutely. Pretty crazy, huh? These are tough. I'm going to do one more. One more. Oh, yeah, one more of these two. Mechanism 4. Okay? Try that guy. This guy's interesting. Got an interesting part to him, too. Something real quick about this one. This is probably pretty easy to tell if it's consistent or not. But there's something else I want to point out to you about this guy. This guy's not only inconsistent because it doesn't fit the mechanism, he doesn't fit the equation even. Well, actually, you wouldn't know that because I didn't use coefficients up front, so I guess that you would know that. I didn't really put coefficients in there. All right, we'll just stick with whether it's consistent with the mechanism or not. Is it? Why not? What would the mechanism have to be for this guy to be correct? What would the rate have to equal? Wouldn't it have to equal K, what? What would I write? A, what? B squared. Everybody see that? Now again, I just made these up pretty quickly, but I realized something else about this. I actually used a third B, but that's okay because I didn't actually put the overall equation. I didn't put any coefficients in there anyway, so it's okay. You don't really know what I'm... Because it's a slow step. Because the slow step is this guy right here. Fast steps that come after the slow step. Wait, let me say. Fast steps that come after the slow step do not affect it. So you say, well, that intermediate's used up here. Is it? No. It's not like I got A used twice now. Because it's in a fast step that comes after it. The intermediate has to be formed from a prior fast step and then use the slow step. That was my point for that one. Okay? All right. All right, now there's one last example to do. Different kind of question, though. Copy that whole thing down. And this is the last one. Okay, so the first questions you're going to get, I think, on 66 to 75 are like this. There's about 2 or 3 like this. Okay? They're a little different than the ones I was just doing. I want you to just go back for a second to the ones I was just doing. The ones I was doing, I was giving you the overall reaction, I was giving you the rate law expression, and then I was giving you possible mechanisms, correct? Here, I'm only giving you the mechanism, and I want you to write the overall reaction and the rate law expression. Now, I kind of cheated there because I didn't put the overall reaction, the actual coefficients that belonged in there, okay? I should have. I told you I just did this one really quickly. But the previous one was. The overall reaction, if you look at the previous one, it was, it does have the correct number in it. And the ones on the book will too, okay? So let's get down to this guy here. Nope, one back. All right, so there is my mechanism. You need to tell me the overall reaction as well as the rate law expression, and I want you to also identify intermediates and catalysts. What the heck's a catalyst doing in here? How would you know a catalyst was in here? Interesting question. We know what a catalyst is. We know what a catalyst does. Can you recognize one in a mechanism? That's a good question. Let's see, first of all, let's identify the intermediates, okay? After you copy that down, we're going to draw a big line across. We're going to identify the intermediates. Skip a line, because that's where we're going to put our actually skip 2 lines. We'll put our overall reaction and our rate law expression here. And we'll call the intermediates circles, and we'll call the, and we'll make them in red. I'll make them in red. I'll have our intermediates in circles, red circles, and I'll have blue boxes for my catalysts. They say, well, there are probably 3 guys up there that seem to qualify. Can anybody see what letters seem to qualify as either an intermediate, that as I've been describing it, or something I haven't talked about yet, a catalyst? What do you think, Kaylin?
D.
D would be 1. F would be 1. See something else?
G.
Yeah, B is reformed, isn't it? At the end there. As a matter of fact, I kind of just realized I wanted to do this a little bit differently. I don't want B right there. I don't want him to be there at all. Let me get rid of him in my equation. You can get rid of him too. I just want D to become, hold on a second. Like I said, I just made this up and I'm kind of, there we go. Let's use that. Oops. All right, let's see it again. All right, this is kind of weird. You have D, by the way, D in red and F are intermediates. D and F are definitely intermediates. Why? Because they are formed and then they're used up again. So you would not see them in a reactant as a reactant, and you would not see them as a product. They don't show up anywhere. They're formed in here, they're used up. Formed, used up. Okay. But B is technically not an intermediate because B is there. But then he's reformed. Crazy, right? So B is what we would call a catalyst. So the actual reaction, since B is used up as well, so B is used up and then reformed, all right? The actual reaction, you could include him. I mean, that's a good question. Should I include him in the overall reaction? Because he's there and he's there. Do we cross him out? Not really, because he's just reformed. He was here and then he is there. So you're not really crossing him out. All right? But then are you going to re-put him into at the end product? You don't really have to. All right? It's kind of weird. The only guys that are really here are 2A, yielding E and G. You see it? Because B is there, but B is also here. In other words, you can put plus B and plus B. You're reforming B, aren't you? He's really not part of the net equation. You see what I'm saying? He's not really part of the net equation. Now, can you tell what the rate law, I'm going to erase all this because it's getting messy here. Can you tell what the rate law expression is for this guy? Well, let's see. Here's a slow step, right? Who's using the slow step? D. What did I say about an intermediate that's in a slow step? Everybody that was using a prior step has to be included. So the rate law expression for this guy, I think we all agree would look like this. Rate would equal K, A to what power? Second. And then B to what power? First. Which is why you kind of have to include B, even though he's a catalyst, in the actual reaction. Okay? We never include intermediates in the reaction. Catalysts aren't always included. Depends on what kind of catalyst. Heterogeneous catalysts aren't usually included because they're just surfaces on which something happens. But catalysts like this can be included in the rate law expression. Okay? And you'll see that in some of the homework problems as well. To be honest with you, I'm not even sure if they wanted the overall reaction, whether you should write plus B and then plus B over here again. I'm not sure about the overall reaction. Probably, I mean, whether you have to write that plus B again over on the other side, I'm not sure. I have to look that up myself. All right, because this is all new to me as well. All right, good enough, but you can all do these now, right? That's the last example. And they aren't going to be anywhere near as hard as these on this sheet. On the ones from the homework, they will be, all right? And the homework is, just so I have it on the video here, it's page 652, 13 to 15, and page 657, 66 to 75.